All right. At this time, I am very pleased to introduce our esteemed presenter, Rachel White. Rachel White is a PhD candidate in ecology and environmental sciences and a National Science Foundation research trainee in One Health and the Environment at the University of Maine in Orono. Rachel has spent the past 4 years researching risk factors of meningeal worm transmission from wildlife to livestock on small ruminant farms across Maine, after one of her own lambs became ill with the parasite. She and her husband raise Finn sheep, Norwegian fjord horses, and various poultry in Maine. In addition, Rachel is also a mentor in our mentorship program this year, so we're very lucky to have her with us today to share her experience and expertise. So without further ado, I will turn the floor over to Rachel so that she may begin her presentation. Rachel, please take it away.
Awesome, Samantha, thank you so much for that intro. Let me share my screen. Okay, can everybody see that all right? Awesome. All right, I'm going to stop my video just so I can present and you don't have to see my face the whole time. So, like Samantha mentioned, I am a PhD candidate at the University of Maine. I study not just meningeal worm, but also some social farmer and veterinarian perspectives on small ruminant and parasite health. So who am I and what do I do? I am a Maine native, born and raised. I have a small farm with my husband here in Maine. We have sheep and horses, various poultry. And what got me into research was really just a longing to better understand the implications of like overlap between domestic and wild animals and the environment. And kind of what really bridged that gap and made me like almost forcibly narrowed that down was a lamb of mine. And in our very first season of lambing and owning sheep, almost right off the bat, we had issues with meningeal worm. And thankfully, this particular lamb, he did recover. But a necropsy did show that he actually did have some inflammation in where we would expect the meningeal worm to have been. So, oh, and this is a microscope image of a meningeal worm that I did take a few years back. So to understand meningeal worm, I probably should cover the life cycle, and it is called Paralaphistrongilis tenuis, quite the name. You might hear me refer to it as P. tenuis, meningeal worm, or brainworm. And we call it brainworm because the adults reside in that brain cavity of white-tailed deer. And those deer are their definitive host, or that natural host where the adults reproduce. The eggs are swallowed and then basically deposited out the other side in their feces. The eggs turn to stage 1 larva or L1 larva. And at that point, gastropods or snails and slugs either consume the feces or the larva can kind of penetrate through the snail or slug slime layer. And that snail is basically like an incubator for the larva. The larva sheds into a stage 2 and then a stage 3, which is the infective stage. Now, if the deer eats an infected gastropod, that means that that larva has a chance to fulfill its life cycle and become a breeding adult. But when our furry friends at the farm accidentally eat one, we refer to them as dead end host because those L3 larvae don't have the opportunity to get to adulthood and reproduce. And because of that, that causes a lot of diagnostic issues. And that's why I call it sort of like a phantom parasite, because like most other GI parasites, we can test the feces and, we can do fecal floats. We can even do like serologic assays to see, what parasites our animals might have. But because our animals are the dead end host for this particular worm, and where they don't shed eggs, we just can't diagnose it. Really, the only kind of definitive ways that we can is necropsy, but even then, that is quite the challenge. And actually, in the moose community, there has been a a moose serologic test that has been developed, but unfortunately, there hasn't been anything for our small ruminants. And of course, when our animals face clinical symptoms or death, that causes economic and emotional effects on us as farmers. So just a handful of examples of dead end hosts. So some in the wildlife community include caribou, elk, definitely moose, especially here in Maine, and bighorn sheep. And then with our livestock, obviously sheep, goats, alpacas and llamas, horses, and even guinea pigs. So the guinea pig case, there was one in the literature. Someone was picking grass that had like chunks of infected slug on it. And the guinea pig ended up getting meningeal worm and it died. I could have added cows to this, cattle. There have been some natural incidences of cows getting infected, but it really is pretty uncommon. So some of the some of the symptoms to look for is basically neurological symptoms. And this can be kind of confusing because other diseases or other issues can cause quite similar symptoms. For example, like rabies, polio, bacterial or viral meningitis, things that like are making your animal, have hind end weakness or circle in place or kind of have like a head tilt or throwing the head back, circling, acting blind. These are kind of the telltale signs of meningeal worm. Again, but some other things it could be as well. So, veterinarians and farmers kind of need to approach a situation and sort of have like a differential diagnosis. And a lot of the times it's a response to treatment that can kind of pinpoint that it was a brainworm infection. So I'm not a veterinarian. I'm not going to talk about like the chemical treatments, what to do. That's something between you and your veterinarian. But animals can recover from this. From farmers I've talked to in my personal experience, the lambs or the animals that have recovered from this, a lot of the time they still display some of these symptoms even after treatment. So that brings me to the project that I've been working on for the past 4 years. So again, I'm here in the state of Maine. What I did was I selected 6 farms across the state, and this in the seasons of 2021 and 2022. I visited these farms all throughout the grazing season. Each one had 2 pastures that I looked at. I looked at sort of like environmental variables, which included soil moisture, humidity, temperature, vegetation type, height, all these different variables, as well as placement within the pasture. So like the heart of the field, the fence line, and then the outside of the field. And what I did was I basically quantified the amount of gastropods at all these kind of random areas within the pasture. And to know these little golden snails, they're called amber snails, they're in the family Succinidae, and these gray field slugs, those were kind of the top culprits that I've found across all these sites. Mostly, I'd say it was like 97% of these snails was what I was finding. So what I would do, I would quantify them, I'd bring them back to the lab, document them, catalog them, and then then I would crush them up by the thousands and pour a synthetic stomach acid over them to dissolve their tissue in hopes of uncovering what viable larva would be left. So here is a really sneaky worm inside of a what we call digested snail. So the snail tissue is all gone. What's left is kind of like the soil particles it eats. And of course, the meningeal worms that are inside of it. So I had to go pick out these worms, and I'm currently doing DNA analysis to actually really pinpoint what species I have, because I found more than just meningeal worm. But again, this is just sort of my focus. I also collected deer fecals from these different farms, and I put them in this Behrman apparatus. This is also a method that veterinarians use to look for like sheep lungworm. So I would look for the stage 1 larva within the deer feces. And at all these farms, I put out game cameras just to really kind of keep track of the true overlap of the white-tailed deer onto these grazing sites. And here is a really fun video, making sure the volume is off because there's some background noise. Hopefully it will play. So this is in the lab. I have a microscope to the left of me, and then this is on a computer monitor. So, you know, this is a worm. It thinks it's in the stomach of a small ruminant, and now it's trying to find a way to migrate into the central nervous system. So for my results, I collected almost 5,400 gastropods in total. And like I said, the vast majority of that were those amber snails. And farm to farm varied greatly in terms of gastropod population and with population over time. So in both summers, we experienced a insane drought, definitely throughout the month of June and partially into July. So that kind of is reflected in the downward steep drop there of the populations. But in some of these instances, some of these farms had just such great habitat for these gastropods to persist even throughout drought conditions, that they were able to rebound, they were able to reproduce and keep on keeping on. So basically, my top two farms that I kind of deemed highest risk, they had very similar patterns of grazing habitat management that was really compatible to snail habitat. And I'm going to get into this here shortly. The bars, this is actually, I should mention, it's a log scale. The bars is just the larval load that I collected kind of throughout the season on the months. So that June, July time is really when I saw most of the larva. But of course, there's some early May, like when the snow melts, at least here in Maine. Yeah. Okay, speaking of larva, the larva, the intensity of larva, so when I say intensity, the number within the snails and also across farms varied. So on average, it was a 2.5% average that farms had it. And this was per square meter. The literature, which really focuses more on wildlife systems, like where moose are, so like they're looking at, you know, wetland habitat or in forests, that sort of pegs the average to be around 4%. Some of my farms in different years, some went up to 10%. So one in 10 snails were infected. Larval intensity matters when it comes to having symptomatic animals. So for the most part, I was seeing snails that had one, maybe two individual larvae, but I had a handful that were 20s and even over 30s, and that is enough to really rapidly kill an animal. So going back to how I am assessing risk, or areas of high risk, I kind of look at these three entities, and the first being the host. Oh, wrong direction. So on the left, just starting with the abundance or the general presence and time of these snails being on pasture, think of, I like to present the image of you're walking in your field and you are just you can hear audible crunching under your feet because there are snails on the thousands. That definitely is more risky than having a small pocket here and there, because you can't really avoid multiple acres of just hundreds and thousands, if not millions, of snails. Um, and then they have to be present all grazing season. So, going back to my graph where some of the farms decreased in that drought condition, or the heat of the summer, they didn't really rebound in population. Those don't really have as high risk as the farms that are seeing these gastropods out on their grasses all year round. And then this coupled with the behavior of these snails. So in particular, these amber snails are known to be climbers, whereas most of terrestrial slugs and snails tend to be more burrowing animals. They like to hang out more where the roots are of the plants, in the soil. Um, and in general, they are active in early morning and at night. And then, of course, remembering the life cycle of the worm, the white-tailed deer is obviously a very important part of this risk formula here. So the deer, they have to be present, but it can be any time of the year. So in areas that experience snow, freezing temperatures over winter, the pellets, the fecal pellets that are deposited over the landscape throughout the winter season are just holding frozen stage 1 larvae, where in the spring they actually thaw out and they're fully viable. So when the conditions get kind of wet and the snails are moving around early spring, so right about now, um, they're crawling all over the white-tailed deer feces and picking up the stage 1 larva. And then, of course, the livestock host. Um, they're, in conjunction with the snail activity in the morning and the night, having the host out with all these conditions. So again, think of like the thousands of snails, the white-tailed deer overlap. Um, when the livestock are out, say they got rotated into a new area, we leave them out all night, and in the morning when those snails are really active, um, that it does increase some risk. But we have to think of trade-offs too. We might not want our animals only out in the heat of the day and risk like heat stroke or something. The next is the pathogen. So as I mentioned before, the larval intensity, we can think of it as the dose. It matters. And it matters with different species. So if an animal were to eat, say like 1 to 5, it depends on the animal. If say it was a sheep or a goat, it probably would be okay. If the animal was a llama or alpaca, our camelids are really, really sensitive for some reason to meningeal worm. As little as like 3 to 5 can make an alpaca symptomatic. With our other small ruminants, 8 to 10 is kind of what the literature pegs. Somewhere in that region is the amount of larvae that like a sheep needs to digest to become symptomatic. And then, as I mentioned before, once we start seeing things 15, 20, into the 30s, like I've seen, that's when symptoms they just get overloaded. They get symptomatic quickly. They can die rather quickly. I was really fortunate. Here's just a case on one of my farms. I was on the microscope and I was counting multiple snails where the larva was just in the 30s, and I knew that their small ruminants were just on that plot that I just had sampled. So almost in real time, I was able to kind of warn them, like, hey, you really probably should contact your veterinarian and get some advice for this, because you're probably going to be having animals pop symptomatic. And sure enough, they did. Unfortunately, like as I was talking to them, one of their sheep died, and it was terrible. But at the same time, they were really grateful to be informed and to know. So on average, an average farmer probably isn't going to know how many larvae your snails are carrying. So that's why, thinking of that host, kind of that blue, everything blue that I mentioned, that's how you can kind of assess your own risk. Another way is the environment that your animals are in. So these snails in particular, they are rather keen on certain microclimates. It could be, uh, you know, the different sizes, it doesn't really matter. It kind of depends on, I think, the plants. So having shady areas, so say like edges that are like hugging a forest, or kind of these plants that have more broad leaves that create more shade, they're making their own microclimate. And those plants are allowed, like they allow that snail to kind of persist all season long. So plants like burdock, nettle, dandelion that have tap roots, they again, they tend to have the broad leaves. They have tap roots that kind of hold the moisture down into the soil. So they have these leaves that collect the morning dew, and they hold the precipitation longer, and that is needed for the snail to be able to move around, climb to the top, be accessible to our browsing animals like goats. So plants like that are in patches or are scattered around your grazing system are likely to harbor um, gastropod populations, even in drought conditions. Kind of related to this is having high and retained soil moisture. So some people think, having low-lying land that's wet, that might be higher risk. Yeah, that makes sense. That's typically an environment where a snail or a slug would like to be. They like moisture. But what I found in my research is even in these areas that are high and dry, if they have kind of these microclimates scattered throughout, like if it's a field that has dandelions, for instance, scattered throughout their grass, they still can have a healthy population of gastropods. Um, Another thing like that I saw with my two top farms of high risk is that they had really intense rotation. And when I say intense, I mean a day, maybe 2 days, that they were moving their animals along. They had ample space, they weren't overstocked. So the vegetation that they were on was never overgrazed. In fact, it was more folded over, um, and animals were moved along. So it had really, really great soil quality. Both of these farms that were high risk, they had great soil quality. Their soils were moist even throughout the hottest of days on the summer. They had great moist soils. Um, However, I will say when they had on some of the fields that had monocultures of grass, no dandelions mixed in. If it was a monoculture of grass and they were practicing this high intensity rotation where the grass was folded over and there was like fermentation underneath that hot folded grass, I found hardly any gastropods. But in areas that, they had the same practice, but the vegetation was mixed. They had mixed dandelions, or there was a burdock here or there. They had hundreds and thousands of snails. So the vegetation matters. And then I had one farm that was kind of moderate to high risk. The majority of their pasture system had absolutely no gastropods on it. But one area, it was kind of their throughway to get to their fields. It was like a walkway where there was some kind of like anthropogenic usage. So like they had a water line and it was kind of like a natural swale, but they didn't really weed whack it often. It was full of nettle and burdock. Right on the fence line, those snails were able to solely survive in that one area. And unfortunately, it was next to an apple tree that was between these two pastures. In the snail, and so the deer came in for the apples in the fall. And it created just this one hot spot on this farm that had otherwise very low risk. So there are definitely different things. There's different management that you can use to kind of lower the risk for these different things. One being not having apple trees between your pastures if you have deer and snails around. So one thing I wanted to do with the farmers that were participating in this study and beyond, like talking to this group, is to kind of figure out some management strategies that you could implement on your farm. One being a kind of one that most of us may already have on our farms is poultry. So looking at pastured poultry, and another one being mowing. So with the mowing, I did a 2-year study on I think it was like a 2.5-acre field. I broke it up into different blocks, and within those blocks, there were different treatments. So one was a 2 years of consecutive mowing, low mowing. 1 year it was mowed the first year, but it was allowed to regrow in the second year. And then there was a control, which didn't get mowed for 2 years. So there was statistical significance with that. The double 2-year mow sites did not contain gastropods throughout either of the seasons, nor did they repopulate in the second year. In the 1-year mow, where it was allowed to regrow in the second year, the I found that there were a lot of immigrant gastropods coming in. There were no egg masses, there were no juveniles. These were individuals that were migrating from a neighboring control site or a boundary site. So, if you have notable issues like your animals are dying, and you have, you could sacrifice another area, maybe like having 2 years of mowing, short mowing, can really cut back on gastropod numbers. But obviously, soil is precious to us. Exposing soil in that way and really reducing that vegetation height, it might cause harm. Thinking of the trade-offs, I'm always thinking of the trade-offs. It might not be the best idea for everyone, but if you can sacrifice, mowing it or overgrazing it even to just kind of cut back on those gastropod populations, it might be worth it to you. The other treatment was pastured poultry. This was a before and after treatment. So I measured on 3 different transects just the counts of gastropods along these 10-meter transects before and then after laying chickens were exposed to the area. And this was around, I think, 150 birds. And yeah, there was a definite noticeable difference before and then after. And this was on one of those high risk farms. So this was a farm that had steady population all year round. So it was cool to see. And this is something that farm is going to actually be implementing in their really high hotspot areas. which is kind of awesome that they're using this. Some other interesting findings not related to meningeal worm is this green banded brood sac. It actually parasitizes the snail. It needs a bird host to reproduce. So it actually forces the snail, it kind of like brainwashes them to climb to the top, the highest point that snail can climb. And then the worm, it kind of does this flashing motion to kind of replicate a caterpillar and to be attractive to the bird host. So then it can complete its life cycle. An unfortunate finding that I found was microplastics within the digested snails. So that top image is within one of those crushed up snails, and also within the deer fecals. All of my farms had plastic. Some were in the most remote regions, and somehow deer or slugs and snails were carrying plastics. So that was an unexpected finding. So I'm kind of winding down here. If you take anything away from today, I hope it's just this very basic recipe card for meningeal worm risk. Just remember, you need white-tailed deer, and obviously they need to be carrying the meningeal worm. You need snails or slugs into the thousands, like lots and lots and lots of snails. You need your farm animal, and then you need that overlapping pasture system that just has that environment that is just that those snails love. So moist soils, dandelions, burdocks, that kind of mixed vegetation. The cook time is the spring into the fall. And when you combine all the ingredients together, it makes for one upset farmer. So that is all I have, and thank you. And I would love to hear some of your questions.
Yeah, wow, Rachel, that was really good. I was expecting it to be good, but I was expecting you to do a wonderful job, but that was really interesting. I'm going to share my screen. Whoops. And I need to, sorry. Move on. All right. So we do have plenty of time to take questions. So thank you for leaving that time. If you have any questions, please go ahead and put them in the chat. Sorry, not the chat, put them in the Q&A, and then we will try to get through as many of them as we possibly can. I've been sort of prompting people to do that. Yeah, if you could do that, that would be great. And then I'll just start going through and answering questions. But I'm going to go ahead so I can let Rachel sort of take a drink and chill for a second. I'm going to go ahead and put up our poll for our end of webinar evaluation. This is actually very helpful to us in getting funding to support our webinars, and then also to pay our presenters, because we actually pay our presenters. Sorry about that. Somebody just showed up. So I'll just let that hang out there for a few minutes and let you guys type your questions in. And while we're waiting, Rachel, I'm just going to go ahead and start with the very first question. And Liz asks, are rabbits also affected by this, such as those that you might tractor as grow outs?
Yeah, so thinking of, that guinea pig example. So like rabbits and guinea pigs have very similar digestive systems. That I have no reason to think that they would not be affected by it. I have not specifically looked at the literature, the scientific literature, if anyone has, either experimentally infected a rabbit or it's naturally occurring. But I'd be willing to bet that, if you kind of have all those ingredients on that recipe card and you have rabbits out grazing, there might be a risk.
Okay, thank you very much. And I had a question, if you wouldn't mind me asking, when you were talking about the poultry and having the poultry out on the pasture and how much that reduced the amount of gastropods you found, do you think that's because the poultry was eating the gastropods, or do you think that they were just like disturbing the manure enough that it was making a difference?
Great question. And there's something that I did not mention that I should have too. I'll get to your question. We actually experimentally infected ducks with infected snails to see if they would become symptomatic or expel the larva out the other side. So it was a process, training them. We had to train them to eat the snails, and then, waiting around for them to poop, like looking at the poop under the microscope, and then observing the ducks to make sure that they weren't getting sick, or if they were. And what we found was about 25% of larvae did get expelled out the other side. And there was really there's no science out there to prove that the stage 3 larva is viable outside of a host for very long.
Okay.
Getting back to your question though, the laying hens are, because they're active, they're always running around looking for bugs to eat. I think that made a difference. There were some papers that suggested like broilers, like your meat chickens, that might tend to be more lazy, might not be as effective, but we need more science on that. And then different ducks, there's a lot of different studies on different breeds of ducks that are way better foragers. So like your khaki Campbells, they seem to be more effective at like snail control and running around actively looking for things like that.
Okay. Thank you. All right. So Nan asks, what else can cause hind end weakness?
Yeah. So polio, anything that's like affecting that central nervous system, even like rabies. So that's why like it's kind of, I call it risky business, because not that like rabies is super common. We have vaccinations for it, but it can be a really hairy situation if you say you're not managing your animals for that, or if you're in an area like in a high rabies situation, sticking your hand in your goat's mouth, that like, oh, maybe there's a chance for that. I've heard like listeria could also cause symptoms like that. Yeah, I think I maybe have maxed out my knowledge of that. I'm not a veterinarian, but.
All right. So Lizzie asks, can you breed for genetic resistance in your stock? Are some breeds of sheep/goats more susceptible?
Okay, great question. So that question actually brings me to like the moose world, because studying this worm, there's way more science into like moose for this that really than there are like, I mean, there's some experimental studies with small ruminants of this, but in the moose world, they've been seeing in animals that have received small doses of the worm, they actually can build up an immunity.
Oh, really?
So yeah, I'd be willing to bet that, maybe like with our cattle or larger animals, like maybe there is some immunity over time as they become exposed to it. But that's a great question. I don't know the answer to that. I've not heard of a different breed that is more resilient to meningeal worm. I know that I might get this flip-flopped. I think goats are more resilient than sheep when it comes to the worm.
Okay.
I don't know if that answers that question.
So Nan has another question. She's curious about treatment. She thought that it was perhaps not treatable.
Oh, it is treatable. I myself have treated it in a sheep. I'm not going to get into the treatment, but your veterinarian definitely has that probably pegged down if they're a sheep or goat or alpaca vet. Um, it is treatable. If I think the timing matters, um, and that dose matters. So, like I said, I called up one of my farmers that had an actively dying animal.
Mm.
Presumably, we think it's from meningeal worm. We did not do a necropsy on that one animal, unfortunately. You know, they treated all the other animals just kind of like a, well, let's just assume they all have it because they were all eating in that same high risk area. And none of those other animals showed symptoms. But yeah, animals can recover from it after treatment, but they still sometimes show, kind of hind end weakness or just being a little off in their gait.
So this is perfect because the next question is from Lizzie, and she says, can recovered animals continue hide chewing after treatment with other cognitive issues resolution? If so, does this ever resolve over time? Because she also mentions as the larvae travel along the spinal cord, it can create an itching sensation in the animal that they chew and scratch to the point of creating large sores. This was the case with a couple of ours. One still has chewing issues unless she's using steroids, trying to decide if she's a cull candidate.
Yeah, I've heard of that too. Speaking to a farmer that had this recently with their alpaca, they said the alpaca did have like it was itchy along its back, and I had not heard that before talking to this person. And then I had talked to a vet, and they're like, "Oh yeah, that is a thing. Interesting." They I don't know how long an animal remains kind of permanently damaged and symptomatic because of that. I know with the farmers that have had their animals, they went through that process of treatment and the animal survived and the animal's still walking around kind of funny. Um, it it was all of my situations they've been meat animals. They were destined for slaughter anyways, other than the alpaca. Um, the alpaca is still alive and well, even though she's kind of like looks like she's drunk. Um, so I don't know. I think that likely they probably could, resume breeding as normal. Again, that's something that I would talk to a veterinarian about.
Yeah, and there's actually quite a bit in the chat about treatment options. So for those of you who are curious about that, there's a lot going on in the chat. There's always a lot going on in the chat because you guys are so cool. And Jess would like to know Scotty would like to know, are these worms regional or across the entire US? And that's a question or something we were talking about, because I know even though our white-tailed deer have the worm, they're infected with the worm, we just don't have a lot of snails. And I don't know, we're in North Carolina, so it's a lot hotter. I don't know if it's just not snail country or whatever.
Yeah.
So, but if you can answer
that's a great question. And early on, I had sort of made myself like a map, like a map across the United States of like in the literature where I would find, these different cases from either moose or livestock. Definitely in areas that are more arid, where there is not a lot of gastropod activity, there's likely not a lot of risk. But remember, it needs the white-tailed deer host. Like the worm can actually make other deer species symptomatic too. So having white-tailed deer, having that climate that's fit for gastropods, that's when you'll probably hear about it and see about it more. So I can't really speak to like specific areas. I think like Midwest, like into the kind of Western US, probably you don't see it too often, but definitely here in like the upper Northeast, like New England, New York, it is here.
And that's where when I sort of started researching this when you said you wanted to do this presentation, and I started looking into it. It seemed like everything, all the research and everything that's out there is from Maine or Michigan or, you know, New
Moose.
York. It's like there's
country.
nothing from North Carolina, you know, or Florida or anywhere else. So anyway, Jess would like you to go more into the details and symptoms in the sheep and what your remedy was. And there's also, like I said, in the chat, there's a whole bunch of information in the chat that's going on in the chat. One of the benefits, and you can actually save the chat. If you look at the bottom, I usually do this in the beginning, but I, for some reason, skipped a slide. But there are 3 dots at the bottom where you would, when you type into the chat, and if you click on that, there's the very thing at the top that's not highlighted at all. So it doesn't really look like it's there, and it's save chat. So you can go ahead and save the chat on your own. And
awesome. I just did that because I would love to create like an FAQ.
Yeah, that'd be really cute.
So, okay, more of the symptoms. Yeah. Okay, so imagine walking out to your flock, and I don't know what animal you have, but it's just not acting right. And this is why, you know, getting eyes on your animals daily is like so important. You know what their normal behavior is, know what it's not. You know, they might try to stand up and they just can't. Maybe their front end can get up and their front end seems strong. Maybe they're like limping along. Usually in my case, it was hind end paralysis. They could barely move their hind legs. And that first group of sheep I had were like so feral, trying to catch this sheep that could barely walk on its hind end was just like probably hysterical to watch, because they just try to run. And, oh my God. Others, it is like a head tail circling. Sometimes like with the moose and some feral domestic livestock, it's just they lose the fear of people. I wish that had happened to that sheep, but it didn't, but I caught him anyway. Honestly, if you go on YouTube and type it in, you might find some interesting videos. If you are into moose, there's a couple interesting moose ones too, but they kind of display very similarly. As far as treatment, again, I'm not a veterinarian. I'm not going to get into that. You can look at the chat. You can talk to a veterinary professional, but I'm not going to get into the treatment.
All right. And so actually, Nan Kennedy had a couple of questions that probably, well, one of them was, you must have been in reference to something you said during your presentation. She said, are you including deer in your category of small ruminants? And then she also asked about remedies, but I'm going to send her to the chat for that. So Nan, just go to the chat, see what you can find in the chat. There's a lot of stuff going on.
So deer, that's an interesting question, because, you know, deer they are a host, and if they're exposed to the same risks that our sheep are or goats are, then, you know, I'm not saying that they're our small ruminants, but are they? Probably.
So can the deer, so the deer is a host and does not die from the meningeal worm, does not have any symptoms. And if they were to eat a gastropod, could they potentially, with that 3rd stage larva, could they potentially get ill? There
have been actually a lot of studies where scientists inoculate, like they take a syringe full of larvae and they just, you know, feed fawns or feed adult animals, just to kind of see like what is their threshold, like how many larvae can a deer take before they become symptomatic. Because in the adult deer, you know, maybe a dozen adults maybe are residing, and I think it was like around like 50 to like 80 is larva is when they started seeing some of the fawns become symptomatic. And that's a good plug. I was kind of scrolling through the chat about like, oh, my lambs have gotten it, but my adult ewes haven't. This kind of goes back to kind of, you know, building an immune system, where our younger animals or animals that are older or more vulnerable tend to be more vulnerable to different pathogens, including parasites. So that study kind of proved that too, which was interesting. The adult deer weren't as symptomatic because they've been exposed to so many larvae for so long. So
okay, so we're actually getting down to the last 6 minutes, so I'm going to try and get through this as quickly as possible. Certainly get a
actually
done here.
Samantha, if you don't mind, I had to do some homework before this because I have a frequently asked question that's asked of me,
Okay.
and I wanted to present it here because I'm sure somewhere someone asked it, but it's along the lines of do the snails and or the larvae persist in round bales, hay, silage, bailage, what have you? And there's like hardly anything in the literature or science that I could find that would support that. There was one study I found out of a university in Wales in the UK that they asked this question. They didn't quite get some of the results they were hoping for. What they found was, yes, gastropods can survive the process of being baled, and they could survive like the fermentation process. If think of like bailage, if they were kind of on the outskirts of the bale, like in the outer radius of that bale, I think they were looking at like liver fluke systems. So, but they weren't able to quantify if the slugs or snails and liver flukes were able to survive after a 90-day fermentation process within the bale. That was kind of left, that was a cliffhanger. But I think it's an interesting question. Again, it's one that I've heard several times. And it's something that I think future science should look into.
Okay, thank you, Rachel. That was very interesting. Bill actually has 2 questions. One is, I think you've already answered about the poultry. Well, you talked about ducks. You did not talk about other like chickens or anything. Or maybe you did and I missed it. Does the larvae survive in chicken poop?
Oh,
you mentioned it with the ducks, but you didn't.
Yeah, exactly. So with our ducks, we found like 24-25%. We're still wiggling and well within the duck feces. We didn't see how long it was going to be like that for. We just wanted to know, like, were they alive or not? Yeah.
Okay. And then his second question is, if you fence off the pastures, how long will the larvae survive if you keep the wildlife out?
That's a really good question. If it's a stage 1 larva, so it's still within the deer feces, it depends on the conditions. If it's a wet season, like the wet spring, it probably will be able to survive for some time. If it's frozen, it's going to be able to survive. As soon as it gets hot and dry, it's not viable anymore. I've looked at kind of older deer poop, or even just dry, hot, kind of baked deer poop, and there was nothing surviving. They were there, but they did not survive. For a stage 3, one that's inside of a snail, it's based on how long that snail is good for. So those amber snails can live, I think it's like 18 months. So they do overwinter, but they do die after some time. So if you did cut your animals off a snail infected area, and you just kind of let it be, and somehow you kept the deer out, give it 18 months, and really all those infected snails should be dead, and there should be like cleaner snails. I think, if I answer that question.
Okay. So Dante and Kay have a similar question. Dante says, so could parasite resistance simply be a lack of snails on the farm? And then Kay says, so if you don't have thousands of snails or slugs in the pasture, you're okay, ?
Right. So That's a hard one, because with some of my farms, there was nothing across the landscape. The exposure of risk of their animals was really quite minimal. But there was one hot spot. This is like over 10 acres, one hot spot. And this is the one that had the apple tree on the fence line. And this one hot spot of just, it saddened me because they had animals that showed symptomatic, and unfortunately we weren't able to necropsy those ones either. But that's hard. Like, I'd say in general, you probably have low risk if you don't have all those snails. If you find that, wow, next to my water tank there are thousands of snails, that might be a problem. If you have white-tailed deer that are coming through, because those snails they're not traveling 500 feet to get to your water tank from where the deer are browsing.
How far do they travel?
So I tried looking at this actually in my studies, and it didn't go over great. With these particular snails, I quantified, I think it was like a meter. Again, everything I do is metric. So like a meter a day. Some say like they kind of stick to like a 16-meter radius within their life. So it's not too far.
Okay. And Nan, I'm going to leave your question up, but it got answered by Laura and Gwyneth. So if you want to go ahead and look at their answers. And Craig wants to know, how are the worms transferred to the snail? So how does the snail become infected? I don't know that I caught that in your presentation either, and I probably just blinked or something.
Yeah, no, I probably was going fast. So there's two kind of routes. One is ingestion, so that snail is eating. I have a photo of a snail on a deer piece of deer feces. The snail eating the poop. What happens is when the deer is defecating, there's like a slime layer that kind of is encoding the fecal pellets, and those larvae are in that slime layer. They're not in that fiber matter because they're not GI worms. Like really, they hug that that slime. And what happens is the pellet lands, the snail covers it, and they eat it. Or through it, if it's a moist environment, the larva is able to kind of wiggle around. They're very active, wiggle around into the snail's slime layer or the slug.
Oh,
yeah.
Okay, so then it's not actually it has to be inside the worm because it doesn't go to because it needs to complete its life cycle that way, right?
Say that again.
So it would so if it's in the slime layer of the snail, how does it eventually get into the snail? Just sort of like wiggles its way around and gets in?
Yep. It like penetrates right through tissue. Because think of it inside of like the abomasum.
Yeah.
It's penetrating its way through organs and tissue.
Yeah. Okay, so I think Liz's question has been answered. All right, we're at 4:03, so I'm just going to choose two more questions. Tammy asks, are the amber snails going to be the primary carrier across the US, or are they just typically found in your general area?
That's a great question. They are found all across the US. So that was the family. They are broken down into a plethora of different genus and species, but in general, they kind of all look the same, and they all have the same like climbing characteristics and behavior. Yeah, I did do a deep dive into like what gastropods are kind of most likely. It's actually those little gray field slugs. And I don't know if those are across North America, but most of the research that I've read has those little gray field slugs as being kind of the ones that are more likely. But again, those were coming from studies that were looking at moose. systems. This is kind of like the first study, to my knowledge, kind of out in the raw agricultural environment looking at this. So in terms of the amber snails, yeah, I think they are nationwide. They're definitely on the West Coast.
All right. And so this is going to be the last question. I'm really sorry, guys. I hate this part when there's still so many great questions, but we don't have time. Gwyneth asks, what kind of ratio of poultry to acreage for the high risk pasture? So how many hens do you need?
That's a great question. Okay, so the study that I did, oh my gosh, I think it was around 20, I'm trying to think of feet, 25,000 square feet and it was like 150 birds, and that number fluctuated with predation and other things. It was quite a big area, and they rotated every 3 to 4 days.
Okay. All right. Thank you, guys.
Yeah, and I put my email into the chat if anyone should want to get a hold of me.
Okay, thank you for that. All right, so I have a few housekeeping items to share before we sign off today. A recording of this webinar and the slides will be made available once Larissa returns from a much-earned break next week. These documents will be archived on our website, and Larissa will also email them to you. A sincere thank you to Rachel. This was absolutely amazing. It's an honor and pleasure to have you with us in our last webinar of the season. I learned so much. I really did. I'd also like to give a special shout out to my favorite partner in crime, Larissa McKenna, and everything she does to prepare for our webinars. And finally, I would like to thank all of you out there for your interest and attention. You guys were wonderful. You really shared your knowledge, which was that's always the best part about all of this. And the people who attend these webinars, it's just everybody shares, and it's like we're a community. I love it. And I really do hope you guys had as much fun as I did, even though it's our last webinar. I'm so sad. In September, we will start back up with our webinars, and it's going to be, we've got a great lineup already. We've started to schedule those. But you don't have to wait till September to see another webinar. We've got them archived on our website, and this one will also be archived on our website when Larissa gets back from vacation, but nothing's going to happen before that. I really hope that your summer is full of not too many terribly hot days, the right amount of rain, and livestock that respects fences. And we will see you in the fall. Goodbye, everybody. Bye, Rachel. Thank you.
Bye, Samantha.